Algorithm analysis, the most important thing in terms of using algorithm. Let's try to figure out why. We all know that algorithm is a step-by-step solution of any solvable problem. Just think for a while, most of the time we have multiple solutions for a single problem. But we always choose a particular one over multiple solutions which suits our demand and situation. For example, if you search for a cake preparing recipe in YouTube, you may get hundreds of recipes over there. Or if you want to go from one place to another, you will get more than one way. So obviously you are not going to try all the solutions at a time. So what do you have to do? The answer is you have to analyze. So the term analysis comes with multiple solutions. If you have multiple solutions, you need to analyze all the solutions and pick the best one for you. So in technical approach, algorithm analysis is the mathematical study of computer program performance and resource uses. It is necessary because each algorithm has different behaviors. In order to select the correct algorithm, you need to know what those behaviors are. The most classic example is sorting algorithms, as we have different sorting algorithms. Suppose you want to deal with some data to be sorted. So if you know that insertion sort is considered best algorithm for sorting small set of data and quick sort is considered best algorithm for large set of data, your task will be more easier. So now it is clear that algorithms are selected based on efficiency. So now question is how to find out the most efficient algorithm for my problem, or how can I say that a particular algorithm is good or efficient. If a program run in less time and consume less memory, the algorithm is considered as an efficient algorithm, because when it's real-time requirement, if your program is not fast enough, is simply not functional. And if your program uses too much memory, simply not going to work for you. That means generally two terms are taken into consideration, time and space. This time and space is known as computational resource. Among these computational resources, time is usually more important than space in terms of analyzing algorithms efficiency. To find the efficient algorithm, we need to know the runtime of any algorithm. So here, runtime is the amount of time to execute a piece of code. Generally, runtime of an algorithm grows with the size of input. So, running time of an algorithm is usually measured as function of input size. For explaining this, time complexity and asymptotic notation will help. Here, time complexity is a way of showing how runtime of a function increases as the size of input increases. And for expressing time complexity in mathematical way, big O notation is used. It is known as asymptotic notation. Asymptotic notation is used to make meaningful statements about the efficiency of algorithms. These notations helps us to make approximate but meaningful assumption about the time and space complexity. Some commonly used asymptotic notation are big O notation, big omega notation and big theta notation. So let's see how to calculate the time complexity of a piece of code. Here it is a small piece of code for adding two numbers. Basically, time is taken for assignment operation, comparison operation, arithmetic operation and so on. Consider each line will take 1 unit of time. And another thing you need to remember, in time complexity calculation, we will always get a time function, not the clock time. So let's go for the time complexity calculation. Here 1 unit is needed for assigning 10 in number 1, 1 unit is needed for assigning 20 in number 2 and 1 unit is needed for assigning the summation of number 1 and number 2 in sum. So for this line actually 2 units of time is required. 1 unit for adding number 1 and number 2, and another unit is for assigning the summation in some value. This kind of analysis is required for detailed analysis, but normally we can consider 1 unit per one instruction. So now add up all the units. So you can see that for this code 3 units of time is required. So now what to do? It's time to express it in mathematical function. And we know that for expressing time complexity in mathematical way, we use asymptotic notation. Here we will use one of asymptotic notation called big O. We can write it O followed by a parenthesis. For this code, the time complexity will be this. It can be stated as big O of 1 or O of 1. Now question can be arise, how can we say that the time complexity of this code is O of 1? For easy calculation of time complexity, we can follow 2 rules. First one, select the fastest growing term, and second one, eliminate the coefficient. Let's take a look on this time equation. Suppose some program will take this time, t is equal to 5n plus 1. For finding the time complexity from this equation, first we have to select the fastest growing term. So here the fastest growing term is 5n. So select this 5n. And now second one is find out the coefficient. Here 5 is the coefficient. So now the work is to eliminate the coefficient. So if we eliminate this coefficient, the result is n. So the time complexity of this equation is O of n. If we have another function like t is equal to 3n plus 4n square plus 2n cube. So for this equation, first we have to select the fastest growing term, that is 2n cube. So select this one, and now we have to find out the coefficient. Here the coefficient is 2. So if we eliminate this coefficient, t is equal to n cube. So the time complexity is O of n cube. For our program, the time is 3. As 3 is the only term here, so consider it is the fastest growing term. So select it. Now we have to find the coefficient and we have to eliminate it. So we can write this equation like this. So if you eliminate the coefficient 3, the time complexity will be O of 1. This time complexity means that the program will take a constant amount of time. The input will never affect the runtime of this code. Here num1 is having 10 and num2 is having 20, and this code required 3 units of time. So if I write num1 is equal to 10,000 and num2 is equal to 20,000, the program will still take 3 units of time. Here the number of operation of this code is not depending on the input. This situation is called constant time and it is expressed in O of 1.